How's everyone doing? How's everyone doing? Oh, echo, echo. What a fantastic thing that is. There we go. All right. Oh, make me log in. Why don't you? All right. We're good. Let's get Edge up and running. Not that. I don't know what I typed. Oh. All right. Let's see. What are we doing? Working on the file system. I actually think we're good here. We cleaned up the code for the most part. Oh, that's right. The file compactor. We were fixing the file compactor. Yeah. So the thing is, the thing that can create this is in the file engine, because the file engine knows what type of engine it is and can create the proper record, what this new record is. So this needs actually the file engine, but we have the DB, so we should be able to do that, right? Right. This is making it out of a line. Ugh. I don't know that I have that. Oh no, we have a serialized, so we can just serialize it, right? Yeah. Okay, so this should be easy. If I remember how to access the database from the compactor, right? That's something up here. Something up here is the database. We have it's just okay. There we go. So we should be able to do something like db dot get file engine. Let's see. Should be like that, right? This returns a result. Ooh, this could get tricky. Let's see. We'll see. Sweet. Okay, yeah, that wasn't too bad. This would just be serialized, right? Oh, does that work? That's gross, right? Yeah, well, we actually want to write the bytes. So we probably just don't want to do this. Anymore. What were we using here to write? I know we used to use write line, but when are we using this? What have I done? What have we done? No, this isn't what we want. Let's see. It could only be like right here. Let's see. Oh, it's right here. Yeah. Okay, here we go. Here we go. We use write all. Where were we? We were in the file compactor. Here we go. So this would then turn out to be something like this. Let's see. Let's see. We could do something like... Oh, I thought it was in insert mode. Not in insert mode. Let's see. Actually, wait. We could... I didn't quite do exactly what I wanted, but I got close. I got close, really close. Let's see. Okay, not nearly as close as I was thinking. I got closer than I actually did. Sergeant Pepper. That's right. It's an Htmx native database. That is right. Htmx native. Carson, what? I don't remember his name. The guy created Htmx. Absolutely would endorse this database as the best database if he knew that it existed. You're afraid to ask? I'm afraid to answer. It can be a mutual fear. Mutual fear. We can have it. Wait a second. Let's just go back to what we did up here. It's the exact same thing. Mutual fear. Sometimes I'm so brilliant, I'm scared of my own inventions. I feel like AI people now. I understand them. I understand their fear of what they're creating. Borrow error. I'm also afraid of borrow checker errors. There are a few things I'm afraid of. My own creations and the borrow checker. Okay. So it's new file again. Okay. Cool beans. All right. So does it build? Cool. We got the Htmx native database building. Yes, we did. Now, compaction is still broken because I think what we're going to do, I don't know if we'll do it this Saturday, but what I think we're going to do is we're going to shore up our consensus and we're going to branch it there. And then we're going to do probably Paxos. And we're probably going to do the full implementation of multi-Paxos, because single Paxos is fairly easy and fairly straightforward, but it also doesn't scale. And so we'll probably do single Paxos. We'll probably call that good. And then we'll probably move on and play around with some of the things like Lamport clocks and things like that to help with our performance. So Sergeant Pepper, or anybody that's new and slightly scared of the words Htmx native database, don't get too scared. Don't get too scared. I'll show you what we're doing. So we made a database, and we've been learning about databases, and we've actually been implementing it in code. And what you see here is originally each key value was stored just in plain text like this. And as the latest update that we've done actually allows us to have these records on disk. That allows us to have schema versions, the version of the record, the string, oh gosh, the index, the tombstone, and what the actual latest value is. So it's been a process and a journey to get here. Now, the cool thing that we did and implemented, this database can run in 3 different modes. We have, let's see, file. We have this file engine that you know what? In 112 lines of code. This is something I actually like about Rust. In 112 lines of code, we enabled it to write it in JSON, HTML, and Proto. And this is going to go into the video because what we're going to do is we're going to understand the ramifications of this. What are the size? What are the CPU ramifications and things like that? So we'll be able to benchmark this and see, like, for 1,000 records in JSON and HTML, how big is that compared to a binary thing like a proto buffer? What ramifications do version proto buffers have and things like that? So we'll get to talk about those things a little bit more. Actually, let's write that down. We're working on the video or stuff for it. Now, as you'll notice, one of those is HTML, which is cool because basically you have a native HTML viewer. I'm sorry, the music's a little loud, isn't it? You'll have a native HTML viewer that can just use Htmx to serve each record, which I thought would be pretty cool. Actually, I do believe who was it? Oh, I'm pretty sure it was Russell that had that idea. So I'm not going to take claim for that. Russell's the inventor of the Htmx native database. These Htmx nerds are going to go crazy over this. Oh my goodness. Oh my goodness. That would be hilarious and terrible at the same time. Where you can just serve HTML straight out of your database into your front end. Doesn't that sound amazing? Doesn't that sound just amazing? What if your database just held it all the render? Oh my goodness. Oh, to update your UI, it would be a database update. Oh, the pain. Oh, I just thought of that. Oh, that hurts. That physically hurt me. Okay. What was I? We were talking about something that I thought was good to implement or talk about. Oh, let's I don't know what to call this section. Interesting things to learn. And one of these things is size. HTML versus Sergeant Pepper. You know, I can't recommend the database, but you do that. I'm actually thinking about making a honest ad style video with HTMX native database. I think that would be hilarious. Because I think there's people that would take me serious, but like it would also be a thing that exists. Like it would be real, right? So I'm thinking about doing it. I think that's a hilarious video. HTML versus JSON versus Proto. Let's see. We're talking size. Let's talk about CPU. Actually, let's redo this. Perf. So we'll do size, load, memory. So we'll try to measure these things. You know, there's going to be a huge difference between HTML, JSON, and the protobuffers. The protobuffers are going to be tiny. Now, we'll see, you know, I honestly think the protobuffers will have less of an overhead for memory with like loading and writing, just due to the binary format. I don't know that to be specific. I know that there's like some really fast JSONs that have like 0 allocations that are a lot closer to protobuffers, but and I know I don't think anybody's actually done performance with HTML ingest, so I doubt it. Plain text. Why have it in plain text if you're basic? The reason to have it in plain text is to be human readable. Why would we do plain text and base64 encode it? Dutch. I think you're trolling me. I think you're trolling me. Security. If there is one thing that is easy to tell, is when something is base64 encoded. It doesn't look like cryptography. It doesn't look like binary. It doesn't look like anything else. Base64 encoding, like, because I heard some people like, oh, it will. No, you can tell if something's base64 encoded. I'm sorry, you can look at it. And the thing is, it takes half a second to check if something's base64 encoded as well. Encryption. That is not what encryption is, my dear friend. It's encoding. Encoding does not equal encryption unless if you don't know it's encoding, and then I guess it could be, in theory, a form of information obfuscation for the ill-informed, which I guess is, in theory, technically encryption. You know, like A equals 1, B equals 2 was kind of a form of encryption, right? Even though it's really just information obfuscation. It's not encryption. Let's be real. Base 63, no one will get it. Base 63, you're safe. Just, you're safe. And bit shift it just in case no one. Just to be clear, everybody, we're joking and teasing here. This is not encryption, and it won't protect your data. We are joking. I feel like everybody that watches me would know that, but I do like to be clear just in case there's a new person. I just use plain text. I use post-it notes, okay? If it's not online, hackers can't get to it. That's the real solution. Just post-it note it. You'll be safe. Trust me. Again, don't take that as anything real. Okay, don't listen to me on that at all. Okay, so what we're going to do, we're working on the file system. I actually got it all compiling, so I fixed the compaction, even though compaction isn't broken. It would work. It would just break Raft. Because Raft's our Raft implementation is all around snapshots, and currently we don't snapshot, so we don't have a full Raft implementation, but that's okay. The reason we don't have a full Raft implementation is because we wanted something that would get consensus, was able to be highly resilient with the ability to transfer snapshots between each other and things like that. That's not part of our goal. If you guys want to learn that, we can, but it's pretty simple stuff. It's just kind of tedious. So what we're going to do is today I think we're gonna actually finish going over the file system stuff. And then we're gonna kind of do the database like this. So today is file system stuff. And I mean, there's going to be a video that goes along with this at some point, hopefully in the next couple of weeks. And then we're going to maybe this Saturday finish up the raft. Not finish up as in like implementing snapshots and everything like that. But we're going to finish raft to make it like we're gonna make the code a little bit prettier. We're gonna make sure it's commented for people that want to read it. We're gonna make sure that we have some tests in place for people to run if they'd like to run. Kind of like what we're doing here with the file system, where we're gonna have some performance tests and some stuff like that. So we're gonna do that. And then what we'll probably go ahead and do is we'll implement single Paxos. We'll implement single Paxos after that. What we'll probably do is we'll do single Paxos, which it doesn't scale particularly well. And that will be good enough for our scaling needs at the time. And then we can do more with that later. But what we're probably going to do after that on the database needs here, we have basic indexing, and we're probably going to do some more with indexes. So indexes, we're going to do some more index stuff. So there's different indexes we can implement. We've done some pretty simple indexing. We did the LSM trees, which were pretty easy in and of themselves. One common one that people have been asking for is vector. So we'll probably do a vector index. And then there's a bunch of other indexes we could play around with. And then the next thing on the list after that is replication. And we'll do replication and consistency. This is where you get databases that can run favoring. So, for example, I'm going to speak on this one because I know it very well. So I'm fairly confident about talking about its capabilities. Not all databases have, the full gambit. But you have the whole cap theorem. All right, and this is where you get, for a database like Aerospike, it can run in very available and very consistent modes, where the database accepts data, regurgitates data very differently depending on what your needs are. There's also some in-between states that you can hit here as well for Aerospike specifically. A lot of databases have that ability, not transactional databases like Postgres. They're usually a little bit more of a stickler towards, they're usually a little bit more up here in regards to that. But again, you have to know what database you're talking about. Rafts are really bad when they're compacted. Yep, they just don't like it. You can build a compaction algorithm for Raft. I don't know that any of us are that interested in, I couldn't find one, so we have to develop it. And I've thought about it. It doesn't seem that difficult, but it would take us fiddling with stuff. If we want to come back after all of this stuff and figure out how to make a compaction for Raft, we can do it. 100%. If you guys would prefer. I mean, we can take Raft and bend it to our will if you guys would prefer doing that over something like exploring another one like Paxos. So this was just kind of my plan for learning for right now. If you guys like this, awesome. If you don't like it, I'm sorry. Find somebody else. I mean, I'm up for talking about it. If there's something people are way more interested in, let me know. We can talk about it. All right. Come on, ChatGPT. Copilot. Give me something. Ooh, this is right so far. Right so far. So far, so good. This is incorrect. This is incorrect. Okay, this is cool. This is good though. A record is a key value pair. This is not entirely true. A record. So a record is a representation in memory. In memory of a on-disk record. Yeah. Ooh, there's an ad in progress. I'm gonna go get a drink of water. I'm gonna like fill my water cup up since there's already an ad going. All right. Sorry about that. Okay. We should document why we were doing this. I know we did it on the old one. Let's all right. I don't think we need to do any of the like this is covering all of these here. So Dane, I know we were talking about last night, and I know that I just told everybody else already, but you deserve to know. I say last night. It was actually well, you were at 1 a.m. with me, so yesterday morning, what I was talking to you guys about yesterday morning, I figured out what we're doing. I'm leaving compaction as is for right now, which means it's kind of at odds with our raft. So what we're going to do is we're finishing up the file system tonight. Raft, we're gonna start working on the raft, fixing that up, getting it video ready, working on the lesson plan on Saturday. When I get those two once I'm done with these two things live stream, there's actually gonna be a break here that's not part of the database. And we're gonna do null cloud stuff. The first thing that we're going to do with that is we're going to implement a swim protocol for clustering. So that should be pretty awesome. If you guys don't know how to machines cluster, we want to learn one popular way, we'll be doing that. But this is just talking about database stuff. So there's going to be a break in between these because I got to make the videos that these power. Once those videos are out, we're going to move on to, and we're going to rip out the raft stuff. Instead of like fully implementing raft, we're going to rip that out and we're going to do another one on Paxos just for fun to see how the two ones are a little different, how they deal with consensus and whatnot. Obviously single Paxos. We can move on to multi-Paxos if people are interested. One thing that people have been asking for is for more index stuff, so we can implement some other indexes. One specifically people would like to do is vector indexes. So we'll probably build at least one vector index. These are actually kind of fun. So we might do more than one. We'll see how it goes. And then we're going to go into making our database be able to run with different forms of consistency and replication and data protection. So we'll get into like replication factors and things like that. And then, yeah, and so that's what we're going to do. So we're leaving compaction as it is, even though it's kind of broken raft, because what we'll do is with Paxos, we'll actually merge those two systems together. That's kind of the end goal. So, and yeah, there'll be like a break here for probably in between each one of these things, there'll be a break where we work on the null cloud stuff. Which we're going to start with Legion. Actually, the API works. We might do a little bit of front end because the API and everything is working. You can actually run a workload, except the UI just doesn't do it at this point. Can't wait to see me do more CSS. Good luck. Good luck on your interviews. Hopefully they do well. I saw this conversation on Twitter about hash maps. And I'm wondering what you guys think of it as a valid recruiter question. I guess it's something that recruiters from Amazon ask. I don't really know. I've never actually wanted to apply for Amazon. And they ask you to tell them about hash maps, and they want to know how far you can go. What do you guys think on that? You say this, and this was my first thought was, oh yeah, hash maps are a great tool, but they're not actually meaning how to use hash maps. Like, that's just like everybody knows how to use a hash map and how long it takes, but they actually like how many hashing algorithms do you guys know? You guys probably, you probably aren't going to think of it immediately, but you probably actually know quite a few if you think of like SHA, you know, SHA, the secure hash algorithm. There's probably more, you probably know more than you actually think you do, but do you know of which ones you use in hash maps, why, and how commonly you're using them? Do you understand the implications of a miss and those types of things? How relevant is it in an interview? Right, yeah, MD5, SHA. So I think we're going to cover that. I don't know. So I go back and forth on this. And you know what? I love Twitter because people like to get upset, but I like to actually think about these things. I like to actually think about these things and sit there and ponder it a little bit. And then I troll a little as well. I actually like trolling on Twitter. But I like thinking about this because one thought that I would go into is like, if somebody actually cared enough to know how a hash map work or a hash set or anything like that, they probably are a pretty good engineer. But it doesn't mean that they necessarily are. It doesn't mean that they have the people skill. There's a bunch of other things outside of that, but just they're wanting to learn about those systems. It probably does mean, because it's a little bit of an esoteric thing, that you don't actually need to know to use one. A lot of people, my daughter uses dictionaries in Python and she understands them. She has absolutely zero idea how they work in the backend, and that's great. So you don't need that. So anyways, I've just been pondering it. Dane, I consider myself somewhat the same. Was chemistry and math, and I did like chemical engineering. And so I always feel like I too have holes. I think this is probably one of my biggest reason, or at least the thing that comes up to me when I go to, there are randomly massive holes in my knowledge where it's just like I've never even thought about XYZ. And all of this ties back to this right here. Just so you guys know, this all got started from me thinking about vector indexes, and I'll tell you in just a second how they all tie back together. But right, Dutch. I agree with that. 99% of the times, you don't have to solve these types of tough problems. A lot of the times they need an HTMX website, okay? That's what they really need. That's maybe not what you're going to do, but that's what they really need. We know it. All right, why was I thinking about it? Because of vector indexes. Well, a good hashing algorithm would... Let's talk about a good hashing algorithm, and then I'll tell you why I was thinking about it. ASF should become something that's much different than ASF. Let's just say it becomes this. So a good hashing algorithm would do this. But if it was good, ASD would become something wildly different. Wildly different. You know what? I'm just making crap up. Wildly different. A bad hashing algorithm would make something really close or the exact same. You know, it would be like INSL. This would be a pretty bad hashing algorithm. So the cool thing with vector indexes, which is maybe I'm gonna be able to maybe double dip here, is one of the index type is bad hashing, because similar things get hashed to similar things, which is what allows you to do that like search, which is kind of cool. It's just a bad hashing algorithm. And I think that's fascinating. Apollo, are you asking me if I'm serious? Because I'm deadly serious. This is vector indexes 101. I just got to let you all in on the big secret. All right. So anyways, when we get to vector indexes, we might start vector indexes by doing like 2 hashes, like doing like a good hash map and a bad one. Like no, we wouldn't do like a map. I just mean like a good hashing algorithm and a bad one. And we might learn that whole thing. Since I think it is actually something people don't fully understand, and it's something interesting to understand. I don't know that you need to. But I think it's definitely good to understand if we get there. So, anyways, let's get back to the code. All right. We need to look through our raft a little. And we probably actually, honestly, this is the thing that needs cleaned up probably the most. We've been kind of doing it piecemeal as we break stuff out. We've been breaking stuff out into the file, which is what we just updated. We fixed the compactor. Our index is not affected by this, right? Yeah, it just uses the file engine to read stuff, right? Yeah. Okay. Okay, so if that's the case, we need to look through. We can actually just, I actually think we're done here on the, what else would you guys like to know when we're going through this? So we're going to check the performance of the size on disk, I don't know. That's not the right way to say this. The amount of work to read it off a disk and the amount of memory it consumes in memory. So we have those things to check performance of, which will be interesting. And I'll do that live on stream whenever I get to recording the video and I know what I want to say. I'll know exactly the type of performance thing. So we'll do that one of these days. Oh no, I did something. There we go. So let's see. These are interesting things to learn. So we're just learning the effects of those. We're covering why and how we're doing it. I think this should be just a really short and simple lesson. You know, databases store more data than just the data you have on disk. For just a few reasons. They make sense. Okay. So we got a lesson plan. Let's start doing this with our consensus, and we'll dive more in on it Saturday. All right. We actually probably have quite a bit to do here. It was in working state the last thank you so much, Fun Pennywise. In the darkest hour. I love how the AI takes your name and makes something about it with like the laughter echoed from Fun Pennywise. You guys really need to update your names. To interestedly game the system in a PG-13 or less way. I do have things on it, so hopefully we'll find out with the first bad actor, but hopefully it sanitizes, but we'll see. Fun Pennywise, how are you? Oh yeah, see, we need to do some things to just clean this up. Basically, we're like, we'll just sleep here instead of doing it properly. Which this works, but isn't right. Game emulator. Don't game emulators usually run on your computer? Are there hardware game emulators? I'm guessing there are. I'm not that much into it. What one did you get? It's emulating a very specific game or a console emulator? Because that's the other thing. Doesn't the emulator usually emulate the hardware? I'm honestly asking. I just taking the little bit that you said and extrapolating out a lot. Pow Kitty RGB Max 10.3. That is quite the name. That is quite the name. I actually liked the PSP when I was a kid. I thought it was really good. I was kind of sad it didn't do well. I actually have a theory about why it didn't do well. When I was a kid, it was none of those things. It was the stupid games they released for it. None of the games they released were like good kids games. Like they should have emphasized the younger children, and they were all like these teen games and like better, and we're like trying to push the graphics. I know that it had cool graphics for handheld at that time, but like I just feel like they missed that. I love the joysticks. I think that's what killed it. I think that they just came out with garbage games for it. Yeah, they marketed it to adult. Like, that's... Like, it felt like... to adult, but not there. It wasn't a Steam Deck yet. Like, they hadn't gotten that, so it then felt gimmicky. Because while it was marketed to adults, like, who would use it over their console that could do way better? I don't know. It felt very weird to me. I could have helped if they had asked. I could have helped them for sure. All right. Let's just start documenting some of this stuff. That is literally it. Is there anything more? Sure. I mean, that's kind of obvious. All right, this is dumb. We'll leave that. Okay. All of these songs are Harris Heller songs. Handle a timeout. What? What? Yeah, Copilot. I don't know. I struggle because there is a lot of doom and gloom around AI. This is my same struggle that I have with blockchain. I see these things that are really cool and have done really cool things. And then the hype makes it where I feel like I cannot talk about them. I can't talk about them because nobody really wants to sanely talk about them. If I talk about the cool problems that blockchain has solved, I'm all of a sudden a blockchain enthusiast who just is trying to steal your money and rip you off. If I talk about the really cool things that they've done with statistical analysis and how they've ragged different things and solved different problems and made something that really can generate text much like a human would read it, which is just astronomically cool and a fantastic chatbot, I would get labeled in the doom and gloomers. I don't know how I don't know how to talk about these things because there's actually some really cool things that it has done. Like the ability that 3/4 of these have been generated for me has saved me some time that I've been typing. Not that I couldn't have done what this did, just saved me time, and that's really cool. So when going up to Ohio, I got McDonald's, and it was a AI that took my order, and it was an AI that got it wrong twice, and I finally had to talk to a human. It was embarrassing. It was embarrassing. Hey, look, the robots are going to probably do better than some of customer support you get in the US these days. I don't know. I'll take my chances. It's so bad at this point where they read a prompt, and as soon as you're like, yeah, but that's not me, they're like, oh, I have to give you to my manager. Might as well just give me a robot that will get me to your manager faster. There's going to be more manager spots. There's going to be more manager spots. It's not wrong. It's maybe a weird way to write it. I'll have to think about that. Yeah, it's not that bad. That's why I accepted it. So what I'm trying to do here is I'm trying to, one, refresh my memory on the code that we wrote several months ago. What, 5 months ago at this point? I'm trying to refresh my mind on it, but I'm also trying to, one thing that I do try to do with this is to comment it well. Since it's supposed to be educational, I want anything that's hard to understand or complicated or anything like that, I want it to be well commented for somebody that goes through it. I put a lot of work to hopefully make these this really educational for people. So even if they don't know Rust, I want them to come in here and be like, okay, it's a struct, sure, but I understand that this is that, and I can move on. I even also specifically write Rust a little bit dumber. So I actually avoid completely lifetimes, which could actually save us some performance here. And the reason I do that is purely just to, yes, I copy some extra data. And I do that because I think it's cleaner and easier for people to read, because it doesn't have any of that scary stuff in there. So all right, so run. Let's see what we're going to do. We do need to fix this here. The reason this is like this is it almost has to be on its own thread. Yeah. All right, so yeah, that was pretty solid. So this is main loop. We wait 25 milliseconds. We run a tick. We call next state. Next state only runs if there's a state that's passed. Yeah. So yeah, this is the part that needs to go on a different thread. Right now, the reason we wait is we start the server so we can listen, and we let the other two nodes also start to listen, and then we connect to all of them once they're all up and running. So what we really need to do is put this on another thread, because what will happen is this will fail. And the other thing is, technically, they don't all have to be connected. In how we're running right now, they actually all have to be connected to pass this. So that's the problem here. We'll fix this. This will be Saturday. We'll work on that Saturday. It won't be too bad. This is the tick, right? The tick runs 25-ish milliseconds. Now, for anybody that doesn't know, generally how these work is, and this is actually really important, and I've never met a language that doesn't do this, so I'm going to say that all of them work this way. There's probably something that doesn't. If this is right now, if this is now, and this is 25 milliseconds. What this does is it will sleep for at least 25 milliseconds. That's your guarantee. It doesn't mean that the thread doesn't get busy, and that happens 45 milliseconds. This line was not well done. Was it? No. 45 milliseconds, 100 milliseconds. All it guarantees is that it was longer than this. So that's something to keep in mind. It's not saying that it will only be 125 milliseconds or 25 milliseconds before it gives back control. It will say, it's saying at least. I don't know. I don't know if people know that or not. It's probably pretty common knowledge. It's not Dutch. This is the tick, right? This run tick. This is the loop that provides the tick. So even in a video game, this would be run the video game action with a delta. And this is actually why video games provide a delta, is we'll go back to here, is because that delta is how much time has passed. Because it's not perfect, and that's why you have to use that delta in the tick function. So usually in a video game, the tick function has a delta. And that delta is how much time transpired since the last tick ran. Because it can't guarantee a perfect frame rate. It can't guarantee a perfect run. And so anyways, this tick here is just saying wait 25 milliseconds, or roughly there, at least 25 milliseconds, run a tick, change states if we need to, sleep for a bit. This sleep is somewhat important because we're on an executor thread. So this allows this for 25 seconds to do other things if it needs to. Be used for other things. Because we could just delete this and thrash the crap out of a thread if we wanted to. So this is actually kind of important. It actually makes us much more efficient. Ooh, hello, 145. I want to learn and master a programming language that do anything. Can you recommend one? What do you want to do? Let me ask you what you find interesting. Hello. Hello. What do you find interesting? I'm going to try to personalize it to you. Bevy is a game engine in Rust, if you want to do that. Yeah. But what are you wanting to do? Like, what's your goal? You know, I write a lot of services, so I could talk about that. And because we can also talk a little bit about stacks and the different tools for different languages that are out there. So I'm waiting for you, Halo. I love how the AI wants to redupe. Look at this. It wants to put the main loop in there again. Ugh. I accepted it just to show you guys. That's fantastic. That's fantastic. Ah, this is actually pretty good. I love how it's like, this is where it's cold. Create fast website and have full control of the computer hardware. It's an interesting statement. So generally websites run in sandboxes. That's why I say it's an interesting statement. I don't know if you're saying that you want to do those both things separately or make a website that does that. Again, interesting statement. generally the goal of a browser is to protect your machine from that application. It's also a very difficult thing to pinpoint a single language. Although, not assembly. Does assembly target WASM? Because assembly won't even run in the browser. Can x80 86 assembly target awesome. I don't think that you can write assembly for a web browser. I could be wrong. You could write an assembly compiler. Yeah, you could write a chicken and egg. Okay, so you know what? I'm gonna give you guys my general advice on this topic. Let's talk about general advice on this, and you can take it or leave it. Here's what I'm gonna do. If you're interested in actually the hardware, you want to learn computer science, you're wanting to do stuff interact with the OS a lot more deeply, there's 3 languages. So I'm going to do this down here where, you know, I'm going to say, let's actually do this. Let's go a little deeper. We'll go firmware. We're going to then do OS. Then we're going to back out up here and do stuff like, let's see, we're going to do web. Web is actually in the wrong spot. Let's do games. Games usually sit a lot closer. Native applications, native apps. And then we'll do the web. Let's see, is there something in between here that I'm missing that let's see. We'll do data science. Okay, so this is not the end all be all. My first recommendation to you, Halo, is this. Languages are tools. Just because you pick one and you get halfway into it, and if you decide you don't like that language and would like to try a different one, do it. Languages are tools. And actually that's kind of the what I'm going to try to get at here is there's a lot of different languages that lend themselves to doing a lot of these different things. And that's why I asked, what do you want to do when you said, what's a great language? Now, I would say down here, you're going to get dominated by a couple of them. So we have Rust, C, and C++. There's maybe also Zig is an up-and-coming one, but I would shy away from Zig just because of the lack of community. So that's why I'm not saying Zig there. This is going to dominate all the way out to here. Rust is kind of the new kid on the block here, so I'll caveat this one. I'm gonna put a star here because Rust is the new kid on the block. So if you're talking game engine, if you want to talk game engine, we'll talk Unreal Engine is my favorite. Unreal Engine. If you're talking about 3D games, Unreal Engine is a fantastic 3D engine. If you're talking about a 2D game, there's also Godot or Godot, depending on how you were brought up. There's also this one, which is a cool open source one. And this one actually has C++, Rust, and Godot script, which is kind of like Python. Unreal Engine is C++, plus they have a blueprints, which is pretty cool. The OS, if you're talking about Linux, let's talk about Linux. This is C and Rust now. Firmware is solidly C. C, and we're gonna do C++ Lite, right? I do know some C++ that's on there. We'll do C++ minus minus. It's like a really, really stripped down C++. It's not even worth it. It's C. I don't think Unity is the most accessible anymore, Dutch. I used to say that. I'm not sure that it is. There is Unity here. So if we're making a complete list, there is Unity. I'd stay away from it. That's a company proven to not care about you. And it is in C sharp. But it's the only one. The engine is actually in C++. Just the scripting is in C sharp. They couldn't care less, but they don't go out of their way to purposely hurt you. There's a difference. I actually really like Godot. We're gonna make a couple mobile games in Godot later this year. I was inspired from some old classic games and I really want a game to play in the airport that doesn't have any ads, that doesn't want a monthly subscription, that's just free. And so we're gonna make some arcade games for Android phones that's just free for people to download and run. That's just like some of the old ones. It's gonna be fun, and we're gonna do it in Godot. And we're gonna learn some Godot script, and it's gonna be awesome. Okay, so let's move on. If you're wanting to do this type of stuff, these are the languages you wanna learn. C and C++ are probably going to have your biggest support of natural libraries. Rust has a great support at this point. If you're looking for a game engine, there is Bevy. I think it's called Bevy for Rust. But yeah, so anyways, if you're going to native, these are all okay over here. You know what, we'll put web over here, and one last one that we got to squeeze in here is like services. Okay. If we're going over here, these all work pretty well for this. Especially if you're doing like a native app that's heavy on the computation or machine level access, you're probably going to want to still stick with one of these. But this starts to open up your ability to use some other stuff. So there's C#, which is fantastic. There's Java, which we don't really talk about a whole lot. John Techie, thanks for the follow. We don't really talk about Java. Wait. Can we scratch that out? Yeah, we're just, there's C#. There's Rust. What else do you? So a lot of native apps are written in a language specifically written. So like if you're doing iOS, it's Swift. Here, we'll just do this list down here. iOS is Swift. Android is Kotlin. I don't know how to spell that. Java. Windows is C#. You get the point here. You get the idea. I think that's the big ones. So you have those. When you're talking about data, you have two big players in data. You have your Python and you have your R. There's MATLAB as well, but I don't know if people use MATLAB. MATLAB's like the academic one and is very expensive. And services is again dominated by Rust. Not true, but I like it and I think it's good use here. Then there's like Go. This is a really good one for small microservices too. I really like it. It's fast. It has garbage collection. It doesn't make you think about those low level things as much. It has okay threading and things like that. You can also use C# here really well. You can also use Java. People also use Python here. I don't love Python here. We can talk about it. I don't think it's a great language. But yeah, here, this is not an exhaustive list. These are just the ones off the top of my head. Don't get too hurt. And then there's only one language you can really use here, and that's Wasm. It's the only language you can use here. I'm just joking. You have Wasm or JavaScript. Or Htmx. There you go. I put it up there. Boom. That's your gambit of languages. If you're looking to learn one, pick something you're interested in. If it's a game, pick a game. If it's a 2D game, you have C# and Godot. If you want to make a 3D game, you have Unreal Engine. If you want to learn Rust, you got Bevy. Go for it. Learn to make a game. If you want to do native apps, find what platform you want and go build a native app. You can do them in all of these languages. If you want to do data stuff, learn Python or R. Ew, don't use Oh, okay. We'll mention PHP. I've got a fair mention for PHP. I'm sorry. I will get this out there for you. So PHP has one really good use, and our friends down in Guantanamo Bay figured out what it was. And if your goal is to torture somebody, you force them to write PHP. That's the best use that we've found for it. WordPress. Fair enough. Fair enough. WordPress. Fair enough. Like I said, this was not meant to be an exhaustive list. We can go on with Perl and other Lisp like Clojure if you like. We can hit the full gambit of languages. This was meant to be a primer. A primer. Therapist said you deserve PHP. PHP is the language you deserve, not the one you need. I want a shirt that does that. I want a shirt. We haven't mentioned Edge yet. I try not to mention Edge every single stream. Okay. Look, I can keep this up all day. You guys don't think I know these languages. If you want a language that is purely academic, poorly academic, then you've got your Haskell here. Do you know assembly language? I love it when people ask me if I know assembly because it probably displays a general lack. Because what assembly language? Assembly language is just the language that your processor speaks. But the thing is, these processors all speak different assemblies. Now, I have used x86. I wouldn't say I know it. I know how assembly languages work. Yes. I know the basics, and we actually are going to do an assembly stream where we write some x86, or maybe we'll do some ARM. Who knows? At some point. That is not this day. I still, even though I can write some of it, I can read some of it, I can read basic assembly too. I don't say that I know assembly. Yeah. Wait, is ARM assembly different than x86? Yes. What does ARM stand for? No, I'm asking. I don't really. I forget the A. I forget. Right. So it's advanced. Sorry. It's Advanced RISC Machine, or ARM. RISC is a reduced instruction set. This is actually a much smaller instruction set. Probably why lower. Well, that's not entirely true. We can get into that, but it's the reduced instruction set. Anyways, yes, it is different. You guys are impossible to please. You guys are impossible to please. I gave what I think is a pretty good primer for somebody that's wanting to learn a language. It's not perfect. It doesn't cover everything. They asked for one language, but they said that they wanted to do everything. And if that's the case, Rust is probably the one that spans the most, honestly. Rust is the one that you could do at every single one of these steps. So if you want one language to rule them all, can do web through WebAssembly, services easily through something like Axum, data science by wrapping crappy Python, native applications easily because it will work with the native SDKs, games through Bevy, OS through just being pure awesome, and firmware through tears and pain and suffering. Rust is the only one that really encompasses them all. So I'm guessing if you really want the one true language, you just have to learn Rust. There you go. Go can't do it because their threading is dented. Python can't do it because your application would be as slow as tar. C# can't do it because Microsoft is watching. It's also a memory managed language. Don't want to do that. C++, actually C++ and C probably could also do all of those things. To be fair. I'm not saying you want to do it, but it could probably do, because it could do the WebAssembly. You can do that to WebAssembly. The services would suck. The data would suck just as much as Rust would. All right. I did a doc commit here. Well, the AI did one. It started it. Not the status of the node, but the status of its understanding of the cluster. It's not even actually the actual it's not, because like it could have split brain. So this is actually checking the state of its understanding of the node. How do we say that succinctly? Tick will check the node's understanding of the current state of the cluster. I don't love that, but that will be okay. All right, just let's read through this code. I think this all makes sense. So on message, we just call whichever state it is on message. On tick, we just call whichever state is on tick. And each of these states is in its own, you know, all of its logic is in its logics file, basically, which should make these easy to document and read. If you want to find the logic for the leader, which is the most logic, you go in this one and you know, this is the leader logic. Okay. This is where we really need to start documenting. This is where there's a lot of if, thens, buts. Lots of buts. We had this. Let's see if I can't find it. Did I move those into here? One second, I gotta dumpster dive in the one that you guys can't see all of. 1 second. Okay, yeah. Here we go. Sorry, I was looking. We had this bug. So this is our, and I am going to try to actually make this drawing for actual working. This is actually how we could get 2 liters. So we had a bug where we could get 2 liters. Which was really cool and interesting to debug. And this was the bug for it. But it's interesting because basically this is like let's see, it's a 3-dimensional map because you have the state, but it's not just the state because there's the 3 different nodes, because this is reaching consensus, all graphed out on time. And so this is where you can see this is a node, this is a different node, and this is a different node, and which state that they're currently in. So it's a 3-dimensional map, but I couldn't find a better way. And it's actually a 4-dimensional because these are communications, these are messages, and these are state changes. So there's a lot of information to unpack in something like this. And this is the code for those state changes. So this is like what steps go through. These are like all of the if statements that go through these state changes for each different one. And they respond differently depending on whether they're a follower, a candidate, or a leader, which is, you know, kind of the cool thing. So yeah. So we should try to document that here though. All right, so we're a leader here, and here we're checking. Oh gosh, this is what you want to do. You just want to type the exact. I love it when it's like, let's just recommend what he's already done. Well, I just want to do this twice. That's exactly what I want to do, AI. Thank you. I just want to do it twice in a row. All right, yeah, that's actually correct. If the term is greater than our current term, basically the other one's gotten elected during a split brain. This was elected during split brain. So that's how this scenario would happen is I was the leader. There was a split brain. The majority were on the other side of the split brain. I continued to run. And then the networks came back together. That leader would actually be at a higher term than mine. And I say I, but this node would relinquish that. Otherwise, if we're the leader and their term is less than ours, this is pretty easy. We say, no, we're the leader. No, we are not going to vote for you. We are the leader. Yep. Otherwise. All right. So actually voting is fairly straightforward for the leader because you're never going to vote for them unless if their term is going to be higher than yours, then you're going to vote for them. That's as easy as it gets. All right, append entries. This should be an info call. Info. What the garbage is that? That's just wrong. Okay. Just deleting it. What? Okay, so this is fairly easy. We'll just document it here. Will append. The leader is the only state that can append. The leader is the only one that can add entries to the log. Okay. All right, let's see. Log. Oh. This is not logging. This is actually our log, the database. Poorly named. Poorly named. Okay. I think there's a bug here, right? No, this should be fine. So basically, this will send a request. And if one of the nodes is offline or can't write for some reason, has an error, it will send the error back. And if it can't reach it because it's offline, there'll be a timeout. So this should work fine. Yeah. Okay. Not a bug. Okay. That's not too bad. That's not too bad. So as the leader, it's our job to actually heartbeat. So let's, I have to look into this. We don't become, no, this isn't even true. It says becoming follower, but we're not returning a follower state. So we're not actually, to actually become a follower, we would have to return a follower state, which we're not. So this is just wrong. We're gonna do a to-do here. I know what we do on the other side, because when we talk about the other things will stay in a follower if they've received that heartbeat from the mother node. But what does the leader do? I think the leader does nothing, right? Thank you so much for the follow. I hate it when we're coding in the shadow of a forgotten ruin. It just, every single time I'm like, this is a bad idea. This is a bad idea. These are forgotten ruins for a reason. For a reason. Bad things are happening. Just worst place to code. Worst. I think honestly, we probably do nothing. Because if it comes back online, well, we'll just keep heartbeating to it. We don't really care, as long as we can still reach quorum. Now, what we could do, okay, so what we could do here, though, we could check if we can even reach quorum. So basically, we could just say, hey, if there's 3 nodes and we can't reach 2 of them, we have to stop everything. That would save us from trying to reach quorum and failing. I think this is an optimization we probably won't actually ever get into. We'll probably move on. We'll probably move on to Paxos by then. Ooh. Done. We'll have that done in a year or 2. All right. Going back. Let's see. We're commenting. Oh, this is good. This is good. All right. I think we did a pretty good job. Like, we actually broke this up. So when we first did this was all in one file. But I think we actually did a really good job of breaking this up into like really readable chunks. Like, it's, you know, here's all the follower logic. And I'm sure, like I said, we have bugs and stuff, but Ooh, I have to get going. I know I usually go a little bit later than this, but I have the news in the morning, or I have the news at lunch, and I have to be fully prepared to do the news, which means I have to spend about an hour now working on that so that when it's lunchtime, I can just, you know, jump on, stream the news. Yeah. Oh, look at this. 1 second. Let's check this out. This went for it. The basic implementation of multi-pack. There is no basic implementation of multi-paxos. This does not exist. This is a paradox. This is a paradox. Impossible. Single paxos, yes. Multi-paxos, no. No. Definitely not. This implementation will cover the essential components, including a proposer, acceptor, and learner roles. Note that this is a simplified version and may not cover all edge cases or optimizations necessary for production environments. These edge cases are probably the thing that's the 99.999% of the code. Now let's create the main components of multi-paxos algorithms. Let's see. Prepare, promise, accept, accepted, learn. Now, my question here, did they go for a leader approach or a non-leader approach? Because what you'll learn is Paxos is actually not explicitly a leader-based algorithm. The really, really interesting part here is, though, that most people, when they go to implement multi-Paxos, actually use a leader because it's easier. What will we do? I don't know. Let's check out what they did here. I don't know this like the back of my hand, but this is like the right words at least. So they made a struct for proposer, acceptor. Okay. GPT is like, I'm so good at this. This is basic. Yeah. I mean, it has the right words. I'm guessing it's very off, but maybe we'll try to run this code and see if it does anything. Let's see. Oh, it runs this in memory. There's no networking. This doesn't work at all. This doesn't work at all. This doesn't, I can just tell you this doesn't work actually at this point. This is really close to single Paxos though. Like a really crappy single Paxos, but it's gotten better at Rust. It has. That is for sure. We'll have to do the AI games this summer. Get your friends, family, everybody that would like to watch the AI games. Chris Titus Tech. Now, I know that he's playing a game, and you all are too nerdy to do games, but I think he's I've gotten to watch a couple of his stuff. He seems pretty cool at this point. He does gaming on Linux, and I've watched some of his streams getting Arch set up. So he's probably gaming right now on Linux. And I always struggle to find somebody late at night. I always struggle. So we're going to give Chris Titus Tech a raid. Capability Snob, I'm sorry you just joined. I am literally just leaving. Go watch the replay of the video. Let it play a little bit. Let YouTube know that this is the content you want to see. It's what you want to see. All right. Thank you, everybody, for joining me. I'll see you tomorrow for the news. And then Saturday, we'll get more into documenting the lesson plan for Raft and understanding where our holes are. We're going to run some. We're also going to start running some of the tests for our file system and stuff like that. So it's going to be great fun on Saturday. Join me tomorrow for the news as well. Go say hi to Chris. And I'll see you guys tomorrow. Bye.